Created some geometry here that they thought would be appropriate for the vehicle. This is what I think where the spoiler is. This is where the rear axle is. This is where the front axle is, and then this is kind of representative of the entire vehicle right there. And then they've got kind of their origin there, and this is the bottom line where their chassis kind of rests on. So they set up a skeleton. They went in and created some expressions, and then constrained their skeleton. They did some organization here. They kind of broke up their vehicle into sub-assemblies. So they kind of said, okay, this is going to be assembly, this is going to be an assembly, this is going to be a sub-assembly here. And so they defined those, and then they kind of divvied those sub-assemblies out to different students. They did some file sharing on TCC. And then this is kind of a little spreadsheet that they created to kind of say, okay, here's the parts that are going to be in one sub-assembly, here's another sub-assembly for the differential, here's the powertrain, here's the rear section. So they're super organized. However you guys do it is kind of up to you guys. But once they got everything all together, they created their sub-assemblies, linked things down, created individual parts, linked things down. And this is, I believe, their motor on their vehicle. And you can kind of still see a little bit of the skeleton in here. Like there's some blue lines in here. And they're very faint, very small, so it's kind of hard to see. They were able to take this and whiten it. And you'll notice that everything pretty much updated very smoothly. This part, kept in that corner there. This still stayed in the middle. The battery's a little bit wider there. So they're able to kind of expand it. Some of the challenges they have, it's pretty complex stuff here. I mean, they've got the front end here. They've got the tire. What is that? The axle. I can't remember what it's called. The axle. Really super technical term. Anyway, so they had some modeling challenges. They had to make this parametric as well, and so setting it up can be a little bit difficult. There's a lot of things to take into consideration. If you want parameters for each sub-assembly, and this was one of your sub-assemblies, you need to kind of set up a small little skeleton in here, each sub-assembly, add a link to the master assembly. But it is doable. So this is their vehicle. There's the final sub-assembly that they were able to design. They put them together. And so as they went, this is kind of how they built the car up. So they just did it part at a time, just kind of created some sub-assemblies and then created different portions of it, linked it all up. And by the end, they were able to get it to parametric. This was Eric's project. I think they had this is the Mustang. And so for their skeleton, they did the same thing. They just kind of set up some skeleton geometry here. You'll notice that it's different for each vehicle, so it's kind of up to you guys how you want to create it. But this is an example of them creating it and then testing it before they went ahead and did their sub-assemblies. So they kind of created a normal one here. They checked to make sure that they can lengthen the skeleton. They changed the height, so some of these little sketches, they're really hard to see, but those actually got bigger. And then they're also able to widen it, so you'll notice that these lines are actually widened a significant amount. So they tested it, and then when they actually kind of built the sub-assembly and the individual parts, they were actually able to test it with all the parts included in it. They were able to really elongate the chassis of their vehicle. So that was pretty cool. Front suspension. So here's the normal dimensions on that. They've got all of their axles in there, and they got their shock absorber. They're able to stretch it wider, and then they're able to stretch it vertically as well, so they're able to make it taller. And then they're also able to increase the length this way. So those might be some parameters that you might want to think about when you're doing the sub-assemblies. It's like, okay, we need to figure out a way to make it so that this thing can update in those different ways. And so, you might have some smaller parameters and relationships for the sub-assemblies that you might want to consider. Okay, so here's another example. They have an optimized lower control arm. So this is at the part level. So after they've created the master skeleton, sub-assembly, parts, they link them all together, they're able to go ahead and start modeling off of the geometry that was created in the part. And so here's the lower control arm with just the regular normal dimensions. I think they had just a couple of small parameters in there. stretch it lengthwise, and then I also do extend it widthwise as well. So you'll be able to work just fine. Okay, so that's pretty much the method behind it. In lab, I think it's lab 4, we have a couple of assignments, we'll have some sub-assemblies that we've created for you to kind of give you guys a little bit of experience. But you guys will be able to go in, grab the sub-assembly, and then kind of morph it, because it should already be set up for you. And then we're going to show you guys how to create this type of structure in either Tuxedo or NX, so that way when you guys are actually in your groups, you'll be able to start planning how you want to go ahead and set up your skeleton, how you want to kind of assign different sub-assemblies, if that's what you'd like to do, and kind of start to get a good idea of what geometry you want to use to represent different features of your cars. So I know that's kind of quick and in a nutshell, but we're just kind of short on time. Are there any questions on like the generic method or anything more specific as well that I can answer for you?
This is really generic. You said in lab 4, which will be 2 weeks from this lab week.
Let's see, we went over lab 2 and 3 this week.
Oh, you did both. Okay.
And so those will both be due next week. So next week we'll be going over
Lab
this.
2 and 3 next week. Start lab 4. All right.
So this is about a week out. So this will kind of give you guys a little bit of time to get with your groups and kind of start planning ahead. I found that it's really helpful if you guys kind of sit down with your groups and kind of really in detail just kind of hash out what you guys want to do your car, or how you guys want to do your car. One thing I'd also like to point out, make sure that your teams have the same CAD package that you guys do. If you don't, let us know as quickly as possible, because there's sometimes compatibility issues, and so if members of your team are doing something in NX6, you're doing things in NX7.5, or the other way around, if you're doing NX6 and they're using NX7.5, you can pass parts to the higher version, but they cannot pass parts to the lower version. So make sure you guys have the same. I'm pretty sure most schools have the same one. If they don't, let us know, and we'll see what we can do about getting that fixed quickly. We'd rather get it fixed at the beginning of the semester rather than near the end when it's crunch time. So, but anyway, because of the CAD package compatibility thing, some of the links might not transfer over, and that's kind of what we're concerned about. But I don't think it'll be too much of an issue this semester. So, are there any other questions?
Maybe you might be going over this in the lab. What kind of things do we want in our skeleton? Like, because you said each team is going to be different per car. But what kind of things do we want to identify so that we? Because it sounds like we need to have that set up before we can move on.
Yeah. So before you guys can even start doing the sub-assemblies or even the individual parts, we don't want you guys to start with all the parts now. We want you guys to do the skeleton first, because if you create the part first, you have to go in and rip that part apart to get it to link to the sub-assembly, and it's just more time for you guys. As far as your question goes, it's kind of up to your team. I know that sounds kind of unfair, but each individual card is different, and so what you want to do is just kind of identify, where things will meet up. For example, like on the Mazda RX-7 that we had for my team, let me pull up that slide. We've got a couple of good visualizations here. So like in here, for the master skeleton, we knew we wanted some way of controlling the overall length of the vehicle. So we put just a line representing from the back to the front. That was our length. And then I believe we had a line from here to here, representing the distance from the center of our vehicle out to the tire edge there. We thought that was an important feature, or an important parameter. And then as far as relationships go, we knew that the tire, well actually that's probably more specific, that's probably more sub-assembly. We knew the tire needed to connect to this disc brake system. Our car actually had a disc brake system on it, which then needed to connect to the axle. And so at each point of connection, we put either a circle, a line, a point, something to show where that connection point was, so that we could apply a parameter to that, so that if we wanted to change that distance in the subassembly, we could. So for the master assembly, you'll probably want the same thing. You want to see what connects to what as far as major big parts. And so with that knowledge in mind, you can create the geometry, kind of constrain that using the skeleton parameters.
About how many variables did you have when you did it?
For the skeleton, I think we had like 5 or 6, just for the skeleton. Yeah, for the master assembly. The simpler you keep your master skeleton, the easier it is for you guys to do the overall modeling and things like that. But you do need to have enough geometry and expressions in there so that you can actually control your vehicle. So finding that balance can be a little bit difficult, but keep in mind that the sub-assemblies and the parts that go into the sub-assemblies, they're structured that way so that you can get all the nitty-gritty details that you need, but you want to do it that way. So you want to be able to move your sub-assemblies and then have the sub-assemblies move the individual parts. So your master skeleton doesn't need to be too specific. It just needs to be specific enough that you can control where the sub-assemblies are going to move, whether that's lengthwise, widthwise, height-wise, that kind of thing. So the actual method we taught a little bit more specific to the CAD packaging class, but that's kind of the gist of what we're trying to do here.
Are there any minimal parameters that we're required to change?
Yeah, so in your final project, you guys will have to show that your car can morph. And so I would recommend having at least a length, a width, and height for your master skeleton. I don't think there's any specific number of required ones that you have to have. I can't really see the value of having a height. I don't see you guys trying to change your cars so that they're like monster trucks, right? But yeah, you want to be able to show that those will. And I think each car has about 140 parts, so setting up the structure should be pretty beneficial for you guys. It'll take a little bit of time getting set up, but once it's set up and you know how to do it, you start putting parts in left and right, and then as long as you're just testing as you go, it should come together pretty quick.
Can you apply constraints across sub-assemblies? Like, if my wheels in one sub-assembly and maybe my fenders in another one, can they be related somehow?
In that case, you can't do from sub-assembly to sub-assembly. You might want to create that relationship in the master skeleton, and then create like a parameter for that, and then have it linked to both assemblies. Because it's just going to control the length of something. So as long as you have the geometry placed in the right spots, you control those 2 lanes with that single parameter of the skeleton. So that's actually something we did because the tire length for all 4 of these was the same distance apart from the chassis center line. So we just created geometry from here to here, and then I think from here to here, here to here, here to here, and then we had a single parameter that controlled all of those. And then all we had to do was change that to the master skeleton, and all of our tires would look out into sub-assembly. All right, we got about a minute left. Any other questions? Cool. Thanks, guys. Sorry about the technical difficulties.
Sure.